30, 60, 90 right triangles. Special right triangles are really important in trigonometry and then into calculus. And I think it's important that we understand how these values are found. So first, we're going to start with an equilateral triangle. If I give you an equilateral triangle, we know that, in this case, all angles are the same. And if all angles are the same, then all sides are the same, hence equilateral. If I drop an angle bisector, so it's an angle bisector, meaning bisects the angle exactly, it also becomes the midpoint of the opposite side. So I now have these two angles up top are both 30, and we have ourselves a right triangle. Now, if the bottom side that was split, right, we have a segment bisector, that means each side has a length of 1. So if I now have a right triangle that has this side of 1 and the hypotenuse is 2, how do I find my third side? Well, we know that a squared plus b squared equals c squared, right? The Pythagorean theorem is our friend. So I have 1 squared plus my unknown side squared equals 2 squared. So 1 plus b squared equals 4. That means b squared equals 3. So b equals the square root of 3. So thinking about the location of this, you'll notice that the short side is 1. The long side is square roots of 3 times the short side, and the hypotenuse is always going to be double the short side. That will work in any 30, 60, 90 triangle. So if we look at this, we've got our 30, 60, 90 triangle with our sides put in. Anytime you're playing with a 30, 60, 90, put your values in. It will help you just calculate and find anything you need. So if we start with the sine, we're dealing with 30 degrees. So here's 30. So sine is opposite over hypotenuse. Then I do the cosine of 30, which is the adjacent square roots of 3 over the hypotenuse. And the tangent, which we know is opposite over adjacent. And at this point, you should say, whoa, 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 I cannot have a radical in the denominator. So we multiply the top and the bottom by radical 3, and I'm going to end up with a tangent of radical 3 over 3. Great. Those are the 3 main trig functions. Let's do the other 3. If I have the cosecant of 30, remember that the cosecant is the reciprocal of the sine function. So if sine is 1/2, the cosecant is 2 over 1. The secant of 30 is the reciprocal of the cosine. So that is 2 over radical 3. And then again, your alarm bells go off and say, okay, that means I need to rationalize. We multiply the top and the bottom by radical 3. So I get 2 radical 3 all over 3. There's my secant of 30. And then for my cotangent, well, cotangent is the reciprocal of tangent. Look at the original tangent, 1 over radical 3. If I just flip that, I just get radical 3 over 1. So you can flip the final answer, but then you're going to have to rationalize your denominator again and simplify. So I always like to write everything out, because then when I go to flip them, I can flip equivalent items that make my job a little easier. So there's the 6 trig functions of a 30-degree angle. It would work similarly if you played with 60.